Hello, my name is Jason from FTC Team Wolf Corp number 12525, and today I'll be guiding you through parts of the engineering section in our notebook and explaining our thought process when documenting our journey through the season. So this video will be more focused on the engineering section, not the entire notebook. However, for newer teams looking for more information about the entire notebook itself, we would recommend checking the official first engineering notebook guide, which we will link to the chat, which I'll paste the link in the Zoom chat later. And in addition, there are examples of entire notebooks from great robotics teams in another link I'll put in the chat. We believe that these resources cover a lot of general information and things you need to know when getting started. Okay, so first off, personally, we believe that an amazing engineering section highlights all the important achievements that our team achieved on the robot throughout the season. Your engineering section should be well documented with detailed, concise information, and it should touch on all the technical aspects of robotics, which includes game strategy, CAD, building, and programming, because these are the fundamentals of FIRST and robotics. For our team, we started off our engineering section with an overview of the game. After kickoff, we summarized the entire game using a picture of the field and talked about what needed to be done during the autonomous, teleop, and endgame period. This allowed us to deepen our knowledge of the game and set up a general outline of our design. So as you can see here, we included a picture of us at kickoff, where we visited the field for the first time and where we brainstormed ideas to tackle the Skystone challenge. The next section we added was our design outline, which focuses down on the characteristics of our robot. We began the section with the design statement, which gives a broad overview of the goal we want to achieve with the robot. And next, we listed out constraints that would limit what we can modify when actually building the robot. So some examples of these constraints are the 18 by 18 by 18 inch cube that the robot has to fit under, a max amount of 8 DC motors, and a max amount of 12 servos. And next we wrote down our game strategy, and this section gives details of clear, concise goals for every section of the game. For our autonomous strategy, we wanted to put a lot of focus in this period of the game because it earns the most points. Our first goal was to scan and locate the Skystones, then transport them to the other side, where we can place them on the foundation. After all of those steps, we pushed the foundation into the building zone to prepare for the teleop period. And then after all of that, once we got down to the general strategy, we came up with any challenges we thought we would face. First, the main challenge would be getting the robot to recognize and find the 2 Skystones on our alliance's side. With this, we actually used computer vision and integrated it with the robot controller phone, but we'll get more into those details later. Other challenges included repositioning the foundation without tipping over the stones and navigating around the field without colliding into our partner. For our teleop, what we wanted to do was focus on immediately grabbing the stones with our intake system. If our autonomous somehow messed up and the foundation did not get pulled into the building zone, our first priority would be actually to do that first. Once we grabbed the stone, we would cross the sky bridge to get to the delivery point and then place the stone. At the beginning of the year, our team decided upon stacking the stones side by side in a lattice-like pattern to create the strongest base possible. However, we later found out that this was way too inefficient because it's a lot safer, but it doesn't earn you as many points. We would then repeat the stacking until we reached as high as we could until the time limit ran out. And once again, a challenge we would face was setting up routes around the field so that we could operate as efficiently as possible without colliding into our alliance partner. For our endgame strategy, we wanted to load the capstone in the depot, retrieve it during endgame, and then place it at the very top of our skyscraper. After all of that, we would then pull the foundation out of the building zone, then park it in the parking zone. And endgame this year was especially tricky, especially due to the height of the skyscrapers. So as it goes bigger, as it goes taller, it's a lot easier to knock it down. And then, so that was one of the challenges we predicted we would face during our matches. So this part is where we started to document our brainstorming process. In this section, we made sure to include a lot of photos so others could visualize in groups, creating designs for things such as the chassis and intake systems. As you can see, our team split up into 3 groups, where each group was given the task to come up with an efficient intake system that could collect and place the stones on the foundation. For example, Group A over here came up with the idea to use something like a suction cup, and although the idea seemed cool in theory, implementing it was difficult, and creating enough sufficient force to grab the stone was nearly impossible for us. As the season progressed, we continued to prototype a design. However, as the meets quickly approached, we needed a usable intake system. And this was another challenge we faced in our journey, and we made sure to document the different suction cup prototypes we iterated through so others could see that we tried an idea, and even though that failed, that was okay. Failures show growth and learning. And so building upon that idea, there are two examples of failed prototypes that we documented in our engineering notebook. So here, the first was a 3D printed vacuum mechanism that was powered by a 40-to-1 Neverest DC motor. Inside there is a fan-shaped turbine, and when it's spun inside the chamber, there's a difference in air pressure which causes a suction force to form. The main drawback with this prototype is that it doesn't actually produce enough power to hold the stone, and it was structurally unstable. So whenever the motor turned on, the entire thing would start to shake, and obviously that's not something we want to happen during competition. And our second prototype was a passive suction cup made of rubber that was originally made for glass tabletops. And one benefit of this was that we were able to get enough power to hold the stone. However, there was no way to drop it. So to combat this issue, we used a servo attached to the string on a suction cup to pull and release the stone. However, this was a big waste because using one small servo for such a small action just isn't worth it. And then moreover, using a suction cup requires a lot of precision when driving because there's small room for error when you're like lining it up and placing it down on the stone. And then after the brainstorming section of our robot, we did a full page chart where we did point calculations based on how many stones we thought our robot could stack by the end of the 4 meets. Here in the chart, there's a point breakdown of every game period. In autonomous, you could earn points by repositioning the foundation, delivering stones, placing them, and navigating to the parking zone. We estimated that our second robot, which was the robot we used in competition, would earn a total of 54 points in this period, and a more in-depth breakdown is shown in the chart. In Teleop, you could earn points by delivering stones, placing them, and achieving the skyscraper bonus, which is achieved if you have the highest skyscraper of both red and blue lines. We estimated that our second robot would earn 40 points in Teleop. In Endgame, you could earn points for capping, moving the foundation, and parking, and here we estimated that we would earn 35. In total, we predicted that we would earn 129 points, and this number proved to be quite accurate after we evaluated our performance at the end of the season. And here, this page is where our programmers tested out 2 different computer vision systems for autonomous. Every page consists of a short description of what we modified on the robot, the pros and cons of the modification, and a decision that states whether we choose to fully implement the change in our robot. For example, here, we started off the page with what TensorFlow and Vuforia can detect and what can affect an accurate scan of the field. Then in our pro and con chart, we list out that TensorFlow is more beneficial because it can detect multiple stones at the same time, and it can also determine the position of them. However, some drawbacks include that any black and yellow object on the field is labeled as a stone, and the light level of the room slightly interferes with recognition. In our final decision box, we stated that we chose TensorFlow because the drawbacks associated with TensorFlow were the same as Vuforia, yet TensorFlow offered better recognition and tracking. So right now, you may be asking yourself, what are the benefits of this system? So I think that this pro and con system is pretty effective because it requires critical thinking to evaluate whether the benefits outweigh the potential drawbacks, and it allows other people to easily take into account 2 different viewpoints and let themselves decide if they would make the change or not. For the 2019 to 2020 season, our engineering section was 83 pages long, but the main chunk of it was documenting every small change, whether it be something major or minor. So that was a quick rundown of our Wolf Corp's engineering section for the Skystone season, but we think in this video we also want to reflect on how we can improve our documentation for the upcoming season and address some flaws that we have now. One of the things we need to add is more detailed CAD drawings so people have a better idea of what our prototyping stage was like. We also want to reorganize and redesign the engineering section for aesthetics so that it is more organized and appealing to others. For example, every time our team meets, we should have a goal and reflection T-chart to evaluate what we got done at the end of that day. After that, we can dive into detail and add pictures and explain the changes we made on the robot. So thank you for watching this video from FTC Team Wolf Corp, and we hope you learned something new from us. If you have any questions, feel free to ask us anything in the comment section or reach out to us through our social media, which we'll also put below.